Human improvisation generates real-time, collaborative, creative responses to highly open-ended situations in various domains, ranging from jazz to emergency response coordination to organizational management to improv theater. Improvisation has thus been the focus of research into co-creative computational agents. In contrast to previous work in this space, our research focuses on addressing improvisational action selection, which is the challenge of selecting a relevant action from a vast action space without a clear set of goals or objective functions to use for selecting from those actions. We propose that improvisational agents can be intrinsically motivated to negotiate creative arcs and select actions accordingly over the course of the improvised performance. Creative arcs are trajectories of actions taken by the agent in a creative space of novelty, surprise, and value, computationally measured from the agent's perspective. Therefore, given a creative arc to follow, over time an agent would choose actions across the action space to follow that arc as closely as possible. We have chosen to study improvisational action selection within the props game from improv theater, where people take turns with an abstract prop to perform actions using that prop as a real or fictional object for comedic effect. We have created an interactive installation using virtual reality for people to play the props game as robots with a virtual improviser agent. After familiarizing themselves with the game in a trial round, during their turn, the human is given a prop and has 30 seconds to perform as many pretend actions using that prop as possible. After completing each action, they hit a buzzer, incrementing their score before passing the prop to the agent when their time is up. When the agent receives the prop, it improvises actions using the same prop for 30 seconds, incrementing its score after each action is completed. In order to better interpret the agent's actions, the intended action and object are announced using a speech bubble and audio. When the agent completes its turn, the round ends, and a new prop is given to the human for their next round. The game ends after a fixed number of rounds are complete. All of the agent's improvisational responses are generated using the CARNIVAL architecture described later in this video. The audience view draws spectators into the virtual world for the audience to view the improvisation occurring inside as robot characters sitting in the stands of the circus. We have implemented creative arc negotiation in an improvisational agent architecture called CARNIVAL that is composed of 4 modules. Given a desired creative arc for the agent to follow, at every point in the improvised performance, the agent searches its action space, guided by a set of improvisational reasoning strategies adapted from human improvisers and prior work. These include strategies such as mimicry, transformation, combination, similarity-based recall, and pattern projection. Currently, all the strategies are executed in parallel to generate multiple candidate actions. However, another module in the future could be used to select strategies based on the agent's current location on the creative arc, the desired next step in the arc, and the relative probabilities of each strategy to best match the trajectory of the creative arc. The agent generates candidate actions for evaluation using a deep learning module called Deep Imagination. Deep Imagination uses a conditional variational autoencoder to search the agent's action space conditioned on the physical attributes or affordances of the prop that the agent is improvising with. Each candidate action that is generated is then evaluated by computational models of novelty, surprise, and value to find the closest action in the creative space.